Okay, so we are talking about section 4.9 using similar figures. So the cool thing about similar figures is that you can measure something indirectly, and that's where this indirect measurement comes from. Okay, so indirectly means that you wouldn't actually take a tape measure up to it and measure how tall or long something is, but if you know that something is similar, you can use a proportion to find a missing dimension. Okay. So it says, for each pair of similar figures, write a proportion containing the unknown length and then solve. So all of these triangle pairs are oriented in the correct direction, okay? So we are gonna assume that they are similar because that's what they're asking us to do. And one little thing that I have a couple tricks when we set up proportions. So first off, sometimes I like to label, like this is triangle A, this is triangle B. And then when I set up my proportion, we are going to be looking for the unknown. So I'm going to be looking for x. So the one thing is that you have to use whatever side corresponds with x on the other side, on the other triangle. So on this side, x corresponds with 12 on the other triangle. And then we have to pick one other side to go with it. Yes. Put names on, then we'll laminate. Okay, so for example, I could pick 5 and 10 or 13 and 26. Many of you might see the relationship already, but we're still going to set up the proportionship. So it doesn't matter. Maybe I'll just do 5 and 10. So we're going to do triangle A to triangle B, and a lot of times I like to write right underneath the triangles if I can. So I would do 12 is to x as 5 is to 10. So a couple things when you're setting up proportions. 12 and 5 both went with this first triangle. X and 10 both went with the second triangle. 12 and x both go together. They are corresponding sides. And 5 and 10 both go together because they're corresponding sides. So there is technically 4 ways to set up this proportion. I'm teaching you a way that you can just set it up and try to keep the sides and triangles together. Okay, so then if we were to solve this, you guys might already see the relationship, but just mathematically you would do 12 times 10 divided by 5, and that would be 120 divided by 5, and you would arrive at 24. So x equals 24. Okay? So they gave us extra information, and we didn't need to use all of the sides. So 13 and 26 we didn't even need to use. Okay, so number 2, we're assuming these are similar. Again, I like to name them. Naming them just helps me keep them separate from each other. Okay, on this one, on triangle B, we're missing side x. So I need to find which side goes with x on the triangle A. Which one is that? Yeah, the 4 centimeters, the side JL. So when I set this up, I know that I'm going to do 4 is to x. And then I have to pick 2 other sides. It doesn't matter which 2 I pick. So maybe I would just pick 6 and 12. I need another highlighter. 6 and 12. Like I said, you guys might see these relationships, but we're going to solve them mathematically. So 4 times 12 is 48. 48 divided by 6 is 8. Okay? I guess this was feet. Okay. Number 3. Again, I like to kind of label my triangles. I'm looking for x, so I need to use the side that corresponds with x on the other triangle, which is 24. So I always start x is to 24, and then I get to pick 2 other ones. So I could do 12 is to 16 or 15 is to 20. Does not matter which one I do. I'll do 15 is to 20. 15 and 20. So then if I did this one, 15 times 24 divided by 20, 15 times 24 divided by 20, and I get 18. So x equals 18 inches. So like I said, X and 24 are corresponding sides, 15 and 20 are corresponding sides. X and 15 both come from triangle A, and 24 and 20 are both side lengths from triangle B. So they kind of have to match up, you know, vertically and horizontally in your proportion. It's really important to do that. Okay, why don't you guys take a second and try to set up your proportion at number 4 on your own. We're looking for X. So 6 corresponds with X. Okay, so if I set this up, I would have X is equal to 6. What other side do you guys want to pick? 15 and 10? Okay, so we did 15 and 10. So 15 goes under the X and 10 goes under the 6. 15 times 6 divided by 10. So we get 9 for an answer. How'd you guys do? Good. Pardon?
18 to 12.
Okay, and you still should have gotten the same answer. Okay, if you did the mathematical part of it, you'd get the same solution, as long as you put 18 under the X and 12 under the 10, or under the 6, sorry. Okay? Okay, so the next type are more situational. I'm going to zoom that out just a little bit for us. It says, Kareem and Julio have a rectangular model train layouts that are similar to each other. So that means that they're going to be in proportion. So Julio's layout is 4 feet by 7 feet. Kareem's is 6 feet wide, but we don't know the length. So one thing when I set up a proportion is I really like to label things. So I'm going to do Kareem's, and I'm going to do Julio. And then we're talking about width and length. Okay, so width and length. So what this does is it kind of just makes a fill in the blank type proportion for us. So if I start with Kareem, just because right here, do I know the width of Kareem's? Yeah, it's 6 feet. So I'm going to put 6 feet right here. Do I know the length of Kareem's? Do I? No, so that's my X. Do I know the width of, Julio's? I was thinking Julia. Do I know the width of Julio's? Yes, it's 4 feet. Do I know the length of Julio's?
Yeah.
And that's 7 feet. So because I have my labels, it's really simple just to plop those in there, and then I can solve. So 6 times 7, and then I'm going to divide it by 4, and I get 10.5. So your answer is 10.5, and then we're working with feet. So that is the length of Kareem's right here. It's always good to make sure your answer is logical. The length is longer than the width of it. Okay, so it says the next problem, a 6 foot tall adult casts a shadow that's 15 feet long. Estimate the height of the child who casts a 10-foot shadow. Okay, so here's how I would set up this one. I would say adult, and I would say child. And then I have actual height to their shadow height. And then I just make my little proportion here, and I'm going to fill in my information. So, do I know the actual height of the adult?
Yes.
I do, it's 6 feet. Do I know the shadow height of the adult? Yep, so I put 6 feet there. Do I know the actual height of the child? No, that's what's missing, and I don't know that. Okay, and then I know the shadow height of that child though, and that's 10 feet. So then I would do 6 times 10 divided by 15. That's 60 divided by 15, so we would get 4 feet. So I would say that setting up the proportion is easier if you put your labels on there, okay? And that is my advice.